Okay, seems we're live. Hello, ladies and gentlemen. Hello, and welcome to today's edition of Total Chaos Meetups. This time it will be a JavaScript one. My name is Mikhail Sergeev, Director of Engineering at Chaos, and I'll be your host tonight. As you can see, this event will be held in English. We will record it for your convenience. You probably noticed that it's an online event. We really wanted to do it in person, as we usually do, but as you know, the COVID situation is not quite safe yet. So we decided to do it this way as a safety precaution. What else? We have two presentations today with a Q&A session at the end of each one. We will receive your questions through the YouTube streaming chat. I will collect them and make sure they're addressed at the end of each of the presentations. So yeah, post your questions there. They'll be answered at the end. Today we have two people with us that don't need introduction, but still I'll give it a try. Rado Stankov, he's iconic in Bulgarian JavaScript ecosystem. You probably met him at many conferences and meetups and other events. He's the head of engineering at Product Hunt, and today he'll tell us more about the React architecture they've built. So hello and welcome, Rado.
Hello, thanks for having me.
Yeah, always a pleasure. Also with us, we have Hristo Chakarov. He's one of our own most experienced front-end developers and a team lead at Chaos. He will tell you about a cool piece of technology that we've been using for great success in one of our projects. So hello and welcome, Itzo.
Hi all. Welcome to the event.
All right, so one final thing, we have some cool prizes prepared for participation in the stream chat, posting questions and so on, and also filling our feedback form that we'll send after the event. So please be active there. And now without further ado, I'm giving the stage to Rado.
Thank you. Let me share my screen. And the usual question, do you guys see my screen? Okay, so let's get started. We have quite a bit of ground to cover. And today I'm going to talk about the Product Hunt React architecture. And this is like one of my favorite topics, like software architecture. Like that's, I think, the most fun thing for me to do. And yeah, I mean, I'm Rado. Here is some links around me. I'm head of engineering at Product Hunt. And together with the video, I'm also going to share my slides here. So if you guys need anything from the slides, you can just pick it up. And you don't need to like screenshot the screen. So yeah, today we're going to talk about architecture and how this fills our application. And the thing with architecture is like you can always present an architecture by drawing two squares with an arrows and say that's it. But for me, architecture is actually how an application works. And for every application, I have this saying that context is the king. Like you have to understand what application you're building, so for you to make like a great application. And I'm going to use like a real use case from one of our latest applications we built at Product Hunt, and this is something which we were working on for the last almost 2 years now, and it's called Your Stack. And it's a brand new product we are trying to build. And this gave us a lot of opportunity to look back at what architecture we used at Product Hunt and start from clean slate like 2 years ago. Now the slate is still clean, but not as clean as 2 years ago. But we also learn a lot of cool things along the way. I'm going to share some cool tricks during the talk. So on, like I mentioned, square boxes with arrows as type of architecture. Your stack basically have like 3 types of like servers. It has a GraphQL Ruby on Rails server. It has like background workers. It's built with Docker containers. It's on AWS. But for today's talk, I'm just going to focus on the React part. Like sometimes in the future, I can talk a lot about the backend, which is actually my strongest suite. But today I'm going to focus on our front-end servers. And we use the front-end servers because we need to have server-side rendering, because most of the information on your stack and in Product Hunt as well is public, and Google is one of our best friends. And we invested a lot in building and having a server-side rendered app. So the front end, we of course used React because we basically know it. And our front-end tech stack includes React. It uses GraphQL to Apollo. Everything is TypeScript. Everything is TypeScript. We use Prettier for styling, Jest for test, CSS modules for CSS, and one new technology which we are trying in this new application was Next.js. And later in the presentation, I'm going to talk a bit about Next.js and how it works. Like Next.js is basically an application framework for building React applications, hidden as a static site generator. And it was one of our, I think, biggest wins, and it was tremendous help. And actually, the nice thing about Next.js is every new version actually removes code which we written because they actually put this into the core. Like, for example, they added native support for CSS modules, and we removed our own plugins on top of that. But when we talk about architecture, and the thing with architecture is that React doesn't give us much. Like, it's even worse than the IKEA build toolkits. And it's very easy when we start application where we don't have the proper structuring and the proper levels of abstraction for us to get stuck at some point. And one of our engineering mottos in Product Hunt is move fast and have breakfast, because breakfast is a healthy meal, and we need to move fast because we're still in startup mode. And we needed to have, again, just rolling around our bikes, building the application, and we should have considered a lot of the things up front. So when we were building your stack, we take a good time and we think about what do we need from this architecture to be, because when we were starting your stack architecture, we actually didn't know what the product was going to be about. I mean, technically, we still are figuring out the product market fit, but we built some common terms we needed to care about. Like the first one was having good defaults. So having good defaults, that means that everything we have we should mostly use the default use cases of it. Imagine like a React component, have almost default props. We should have a good code organization, like this is a must, I think, in most projects. We should make the common operations easy, like from Product Hunt and from other projects we worked on, we identified common things we as engineers and do as features. And those are features the users don't care about, but they're very important for the overall quality of the application and the performance of the developer team. Also, since we are talking about JavaScript, and in this world, it was very important for us to isolate dependencies. Like, it's very easy in the JavaScript world just to get like a random npm package, put it in our project, and then be stuck because we depend in too many places of it. So we built a very rigorous rules around isolating dependencies. And the final piece was we wanted to have the whole system to be extendable and reusable. So for example, when we want to build a new product, we can actually take all the learnings and tools and reuse it in similar way how we actually took a lot of the learnings from Product Hunt. But overall, the most important thing, and everything is was that we need to ship fast. And in order to ship fast, the common things we do must be easy for developers. But again, talk is cheap, and I'm just going to show you the code now. So I'm going to use as the use case, this is the profile pages of your stack. This is like a regular page. And if you open your stack, this is basically what you're going to see in our front-end folder. This is where all our front-end code lives. And during the talk, I'm just going to walk through all of this and explain what's their purpose and why they're here. So when I look at this a system, and especially a system like this, I have identified 3 types of code needed in this application. And I think that split is actually very applicable to a large array of applications. Not every application, but at least most of the application I worked on, the split is you have a support, you have components, and you have pages. And the way I look at that is that the things which the user sees is the top of the pyramid, which is the pages. Like that's what they're mostly seeing. And the pages are built on top of like reusable components, and the reusable components use a lot of support code. And a good way to visualize this is if you think about the old animation Voltron. I don't know actually how many young people actually know about that animation, but the idea there is you have those pilots who piloted those big robots who actually combined into this other big robot. So this is a very good explanation about how I think about the type of components. But when I look at the folders, I don't have a folder. I mean, I have folder pages, I have folder components, but is everything there support? I mean, not exactly. Like the thing which I consider support is the blue folders. The things which I consider components is the components folder. And again, we have pages, and we have those things which we think as pages. And some of this is specific to us choosing Next.js, and I'll go this in the end of the presentation. So the first thing I wanted to talk about is support. And the first thing from support is config, and that's very explanatory, but it's actually important. We actually have a single config file for the whole application, and every config information comes here. Like a lot of projects, especially backend projects, have like thousands flying env configs, and it's very hard to actually see what are the configuration options of the application. We keep our configurations at bare minimum, and everything starts from here. And Next.js has like its own configuration tool, like it has its get config, which takes configuration for Next.js, and we actually wrap that. We don't reference the next config anywhere in our application. We use our own application, and we exposed a lot of configuration. One configuration option is environment. Like for example, are we in test environment? Are we in production? Is it a browser? Because actually this environment browser is a very important check, because we have server-side rendering, and every page should be able to be rendered without a browser. The next folder is the GraphQL folder. Like this is the place where we use this tool from Apollo called Apollo CodeGen, which allows us to connect our GraphQL types and generate TypeScript. So what it does is it talks with the Rails server, which gives him GraphQL types. It gets from Apollo the GraphQL queries and fragments we're using in the application, and it generates TypeScript files. So for example, if we have this code in our application, which is a GraphQL fragment, and GraphQL fragment is basically a description of what data you need from a certain domain object. Like for example, this is the profile avatar fragment. It's a fragment on the profile object in the GraphQL server, and it says this profile object needs ID, name, kind, and URL, and image URL. So this is something we define on the application level in the front-end app. And through this command, we generate TypeScript interfaces for every fragment. So for example, here I have the profile avatar fragment, and I can use this fragment in my code. So I can say that the profile avatar component expects all those attributes. And the nice thing about this is it's type safe. So for example, if I want to remove a field or rename a field in my backend, I can do it, run this command, and it can tell me, oh no, this field is used in those two places. And I can change the places, TypeScript can complain, I fix it, and I have this clean system. And having this actually leads to that we don't have any runtime errors of undefined is code somewhere, no is passed somewhere. The only errors we get from this type is from some external libraries, which we are trying to remove, but we don't get any API problems that the API have returned something and we didn't pass it by. So we just import this, and then I see this like magic. Like I come from the days where we just have some random undocumented REST endpoint, which just give you a JavaScript object and you just use it all the from the website and you just like grab it. But having the GraphQL and TypeScript was, I think, one of the biggest type savers. The other utility level things we have is hooks. We are very heavy users of hooks. Basically, I think we have one or two class-based components, and most probably we're going to migrate those to hook-based. Like we are all functional components with hooks, and we are very, very heavy into the hooks. Like we use them very often, and we haven't had any problems with those. And we have a lot of custom hooks. Like for example, use key hook is helping us have like a shortcut. Like we pass it a key and a function, and every time the component is on the page and somebody clicks the key, it's visible. We have this mounted hook, which is very useful when you have components that might disappear. We have this interesting use height on top hook, which is used to hide elements when the browser is scrolled to the top of the page. It's basically imagine you having like a scroll to top button. And we also have custom components on top of Apollo. Like for example, we have this use GraphQL fragment hook, which you give it GraphQL fragment and it gets into Apollo's cache and tries to fetch the data. And what we have is on top of it, we have built a hook, which is use viewer, which gives us the currently logged in user. And I mean, we call it viewer because viewer actually represents logged in and logged out users at the same time. And we have a special function which actually check if the viewer is logged into the system. And those three hooks are built on top of each other. And this is, I think, one of the best features of hooks is that you can actually compose it and build them on top of each other in a very clear way. Like, for example, when I use is logged in, I actually don't care that I use GraphQL in the background. Those two folders, which are server and static, are Next.js specific. Like server is basically the Express.js server, which Next.js uses to render the server-side pages. And we have a couple of our own plugins there, some for security reasons, some for like we need proxying some stuff around course. And statics is just like a place where you just put all your static files. Like for example, if you need to verify your website through Google or Facebook or Twitter that you're the owner of the website, they give you like this file and you put it in static. Styles is where basically we have our configurations for styling. We started very early on defining a lot of design tokens and a lot of variables and a lot of CSS lookalikes, so the site looked very consistent. And as me as an engineer, I don't have to think about like font sizes, spacings, and all the other stuff. Types is just the TypeScript types. Like we have a lot of like utility types. We have a lot of things here which are related to like TypeScript. Also, this is the place where we put libraries which don't have TypeScript support. We actually built polyfills for like type polyfills for them, and we just put them in types. And the next folder is utils, where we put all the utilitarian libraries. And we had discussions, should hooks just be in utils, but we decided that it's easier for engineers to actually say import something from hooks instead of import something from something hooks. And also it helps with code splitting. So yeah, utils is where we put all the stuff, like almost everything. So for example, for utils, we use, let's say we have a function which formats dates. Like this is something every application needs. And what we have here is we have this function which formats dates. And this is the only code in our system which is allowed to specify date formats. And the reason for this is when we started building the application, we were using Moment.js. And I mean, you guys know all the problems with like all the drama around Chrome, Dev2, Slidehouse, and Moment. But we did this like a year ago because Moment.js was only used in this date TypeScript file. And this date TypeScript file was used from the components, and from the pages onward, we were able to actually replace it with date FNS. So we did this change, and we have a lot of places where we show dates, like almost every site have that. But we were able to just make like a 1 hour pull request of replacing one library with the other. We had unit tests as well for this, so we actually knew that stuff works, and we are able to wrap those dependencies. And this is the process we are trying to take for most of the external libraries you use. We don't do it for all of the libraries. For example, Lodash, they have like a very good code split, and we use them, and we don't see them replacing very soon. So we don't wrap them, but for a lot of other libraries, we just wrap them. The next thing is we have a lot of external code. As much as I don't like it, and actually very dislike it, we need to integrate with other systems. For example, we need intercom, we need Sentry. So if there is exception, we can track them. But we have grouped all the external dependencies, stuff which is not controlled by us, not written by us, in this folder, and they have a very good facades which split the whole system. So it's very easy for us to actually see how they are used and turn on and off them when we need to. So that's the utils. The next folder is components. This is where we put all the components which are planned to be reused somewhere else. Like, we don't put every component here. We put components which are used at least 2 places. And the reason for this is we don't this is like the place where you know that if you make a component here, this component, when you change it, it would affect at least 2 places. And we don't split the components between functional, class-based, containers, and presentational, because the way we think about it is, me as a user, I don't care about that. Like, I want to use a component which is reusable. I don't care, is it a presentational, is it getting the data, should I paste it? I just care to use this component, and I give it the props. So we have a very simple structure. The whole component is on a single level. Like, the component here is the reusable one. If there is subcomponents, like if this component is very complex, like I would actually show you one such component later, this subcomponent is private. We are not allowed to use this subcomponent anywhere else inside of this component. Here, we use component as directories. Like, here is the fragment which describes what data this component needs. Here is a mutation which explains how it can change data. Here we add the icons, which most of the times are SVGs, because they can scale. Here we have the CSS files. Here we also have utilities and in those utilities, sometimes we have custom hooks. So, but me as a user, I don't care. I just use the components. And we have a lot of like presentational components, like we have a font component, which just have all the component folders, and we are not allowed to use font size, line height anywhere else. And again, it's a simple presentational component. Here is its style. We use CSS modules for it. So we basically like very much CSS modules because we can compose them and we have CSS variables and they work quite well for us. We also use this trick where sometimes the component needs to be like paragraph instead of spam. We pass it as a component. Sometimes we need the component to be, for example, a link, which has the style text. And this part in particular is a bit problematic sometimes. We also use a library called class names to composite class names. And that's, I think, a big reason why we use class names. We compose class names, and our goal is for components not to need to accept class names. Like a lot of components now, we have a very good tool set we have built in tools, so we actually don't need this, but by default, people add it because it makes their job faster. So yeah, this package class names is very useful, and so we see return on. The other thing we put a lot of effort is something where we don't put a lot of effort in general, is forms. And we put a lot of effort of having a good form abstractions because this is something we have to do all the time. And we are always in a rush to do so. So we have this form abstraction, and this is how most of our forms look like. We just say form mutation, we pass it a GraphQL mutation. We say when this is submitted, what should happen. We can say what's the name. From the name, we can guess labels. We can also override labels. And we have different controls like emails, text areas. And we also support custom inputs, like, for example, photos inputs and topics inputs. And we noticed that forms are in general state machines, and they have this state, which is input. When the user is done, they load. We have success, failure. And it's like, okay, when I submit, I go to a server and server tells me what happens. And we have standardized, especially the error part. Like this part, I don't want to deal with it. Like we as engineers, we always forget to check error handling and all of that. So we always have by rule to have, like, of course, server-side error validation. So we have a format that every mutation we have in GraphQL follows this format. And this format is totally understandable from our form component. So we don't need to add extra code for our backend validation to propagate into the front-end UI. And this saves a ton of work. Like we have this form, basically every mutation follows this template, and on the backend we basically have like a reusable class. We just overwrite it, and then you get all those features for free. And this helps us a lot with basically integrating it across our system because they are talking with each other by this protocol we built on top of GraphQL. Another thing which is very common for forms is to have custom inputs, and we basically support to have custom inputs like this. Like this is a very complex input. Like you can search, you can remove stuff, you can add more stuff, and you can write this component in isolation, and you can actually make it reusable and use it into forms. But in the code, you just say, okay, this is my control. And we have a very simple interface that this component must follow. It basically needs to accept two properties, value and on change. But a lot of people ask me, okay, which form library do you use? Is this something open source? And it's like, no. I mean, we use a form engine below our form because I don't want to deal with the minor implementations. But if you notice, like you wouldn't know which form library we are using. Like the two best ones, in my opinion, are Final Form and Forming. And to be honest, we use Final Form We are very happy with it, but you as a user, you won't notice. And I think this is the proper approach, because in the future, if there is like a third library or one of those libraries breaks, we can just replace our base shell on top of that. And we have built on top of the already existing forms, the unified styles, common interface. It gives us common interface. We have custom inputs, and it understands our GraphQL backend. So it saves a lot of work, and it works out of the box. Another thing is, again, we have buttons. And one thing which a lot of people do with buttons is, yeah, okay, I'll give you, like, for example, the button can be linked. But what we do is, if the button's on-click function returns a promise, then we actually have ability to show loading text or disable the button. So until this promise resolves, the button doesn't handle. And another things we added on the button itself is a lot of common things we need to do, like confirmation window, like, are you sure? Also here we add, like, for example, what's the mutation? And like basically this goes to the server, it understands the server, it understands how to read the errors, it shows the loading text, and when it's done, it knows how to handle this. And another thing which I didn't have time placed on the slides here to show is basically having require login properties. So for example, if the user is not logged in, we ask them to log in, then we return them to this page. And this is something that people, it's very easy to forget. And this is and for us, it's very easy to just add. Like, again, we also have packages for the different buttons. Like we have button.bordered, button.solid, text, icon, and so forth. And again, the way we think about everything is like you have utility, styling, and domain. Like, for example, this is a like button. Like it clicks, it has a domain logic. It's the like button uses the button. And this is a domain component, which we call answer card, which it has a lot more data here. And the answer card uses the like button, which uses the button. And the like card itself looks like this. And everything here is reusable. Like some of it is presentational, some of it is not, some of it, but we as developers, we don't care. Like we have a box component, we have a card component, which allows us to place things. We have a title, we have another card, we have a date formatter, we have like buttons. So this actually has domain logic and it has presentation, but they're all combined. And me as developer, I just build them by pieces. And here, for example, I don't have a custom line of custom CSS. And this kind of looks like atomic design. Like if you just squint about it, but it's not exactly. Like the way we split components is we have generic components, which are like buttons, buttons, text, forms, and we have domain components, which represent the domain logic. Like this is how we split our components. We don't split them by name, we just split them like in our heads. And the final things which we have is called pages. So pages is basically the things which the user see. And the first thing from pages is this path stick. And this is something I use for ages, and I'm surprised I haven't seen it in any other places, is we have a JavaScript export, which have functions for every route we have in our system. So here we actually have every route as a function, and we never use strings in our routes to present routes. So we can change routes. We have type safety kind of in our router. So we actually never get 404s, which are forced by our links. Usually when you get 404s, is some person visited something else. And the way we use that is we just import these paths and we can say, get me to the root, get me to the static. Again, those return strings. But we also have type safety that, for example, profiles shows a profile, and we know that the profile we need has to have like this username. Layouts, I mean, this is a very simple concept. And the reason here is like the UI, like this is a page, But from this page, only this is unique. Like the site menu, the header, they don't change between page reloads. They are basically the same content here. So we have the concept of layouts, and they're separated because there is like a rules how for them to be used. And also we have nested layouts, like this is the shell of the whole app. And this is, again, the page. This is the layout of this profile page, the concrete profile page. And this is the page, the whole thing. And the final thing is pages and routes. This is like, why do we have pages and routes? And the thing is, Next.js has this file-based router, which is brilliant when you think about it, because it can scale infinitely. It's not like a big config file with thousands of rows, like we have, I think, a couple of hundred rows. But the thing with Next.js is that every JavaScript file here, which every exported component from here, becomes a route. And we are very heavy of having like our pages have a lot of subcomponents. So I don't want any of my subcomponents to become pages. And so I want to control this. Also, I'm not sure if I'm going to use Next.js forever, and I don't want to depend on their routing system. And also, a lot of times routes, the way they're in the file system is different than the domain need for them to be split. So what we do is we actually put the pages in routes and the routes in pages. But yeah, I mean, that's Next.js. I mean, I hope Next.js add this like a config someday. But routes are actually where our routing is. And here we actually have these guidelines that if the folder becomes with us a lowercase, it's like a package. So for example, we have routing and we say profiles, and this groups all the profile pages, the show page, the edit page, the votes page, and a lot of like custom pages. And then the show page have its own like subcomponents, query file, which gets all the data we care. It has custom styles, utils. And the nice thing about having those subcomponents, first, they're like small components. Second, when I change this code, I know what the impact is. Like the one thing to think about, and that's something with our directory organization, is when I change a file, I know what the impact of this change is. Like if I change a subcomponent in a page, I just know, oh yeah, I mean, the only thing that can break is this single page because this is not used anywhere else. If I break a layout, this can actually break a group of pages which uses this layout in a very particular way. And if I break a component, I can break it in a lot of places. So I have to be a lot more careful about it. And the other thing we noticed from pages are they're kind of a state machines. Like they have a loading state. They can go to error state. And this error state can be the server failed, the page is not found. Like, for example, wrong URL in terms of like we try to find the user that doesn't exist. It can be authentication error, authorization error, and a lot of various things like that. And we also, when we move to this loaded state, like the data is loaded, we need to, for every page, we need to consider concerns which are basically for every page. Like, for example, SEO tags or analytics, like we need to track this page was opened, and a lot of like custom things like that. And then we need to render this page. And the only unique thing is the render part. All of this is the same for every page. So what we did is we have this function called create page, which basically just 1 second to drink a bit of water. So having this helper here, it allows us to abstract all the loading of data or error handling, authorization, permissions, feature flags, SEO tags, like what data we need to load. We just say, okay, here is the GraphQL query, here are the query variables, they come from the route, load. We just need to give it a component, and this component accepts the data. But since we know which is the query, we actually know what type of data we loaded based on the GraphQL connection. So we actually have a type safety and we don't care about what's the data here. We here have different flags. Like, for example, is this page only allowed for logged in users? Like, if the user is not logged in, we just automatically go to please log in. And then we go to like feature flagging here. We have permissions here. And again, some SEO optimization tags like custom cell tags or name of the page. And this is again for every page. And again, we use GraphQL to get all our data. So having a page like that, we actually split it into smaller fragments, like viewer fragment for the header, profile layout, profile show page. Those fragments are also deep down because those are also components and they go deeper down. So when we say a query, it actually gets the fragments of all the components needed for our page and gets them into a single query, like something like this. Like, this is the query. This is all the data required to load for this page. But it's just one request. Like, again, I know it's a lot, but when this all combines, it actually makes it very simple because we just pick, okay, I just need this component, this is the data for this component, and everything just works. And this is a lot of the default actions we do. So a bit of recap, like we had a lot of stuff to cover. And the first thing is, again, GraphQL was one of our core decisions. Like, we are using GraphQL, so we built everything with the assumption that we have GraphQL. On the component side, we are very meticulous into isolating dependencies. We are using a lot of directory as folders and like black boxes. And we have this concept of domain components where we actually represent domain entities with those components. On the pages side, I think a couple of takeaways for you guys are the paths helper. It's amazingly simple and amazingly powerful at fixing problems and help you rename routes. The layouts is, again, a very interesting concept. It's very popular in the Ruby world where it's like part of Rails. In the React world, I haven't seen a lot of people use the terminology. Usually they have a component which is like a frame and it's in the folders, and you don't know if this frame should be used as a page holder or as a layout. And create page, like create page, I think is something which basically every project needs, because most of the pages you build basically have the same initial states and flows. So yeah, thank you very much. Here, the slides are here. I mean, we'll share them again after that, and I will be happy to answer any questions if there are any.
Thank you, Rado. It was very interesting, all those architectural blocks you presented. We have a question from our chat, and I would also like to encourage all of you to post more questions. So the first one is, how do you decide to define something as a subcomponent?
So it's basically the idea there is we start with one component, and this component becomes quite big, and there is a lot of logic inside of it. So we just want to make it smaller. Or, for example, we notice that, okay, this component have two states or two hooks, but those two hooks are not connected with each other. They're connected with this part of the component and this part of the component. And then we split this into a smaller component. And should we make it a separate folder, or you should keep it in the same file? Depends how big is it. Like, if it's a bit bigger, like by bigger, like if it has like 3 imports which are not needed outside of it, for let's say, we just move it to a subcomponent. But overall, we try to just keep the component small and readable. Also, a lot of subcomponents are split as a baby steps for making them reusable. Like, for example, when I was building this example here in the forms, like when I built this component here, this search box, originally it was a private component for this topic picker, because we didn't have any search boxes anywhere in the system, but I knew that at some point we're going to have one. So I intentionally split this component into a separate place. It was a private component just for the topic search. It was basically prepared to be moved out at some point. And when the time came, I just move it, clean it up a bit, like make its interface a bit more usable, and make it as a generic component. So now we have a generic search component where you just give it like a couple of options and it can basically search, because it turns out like making a search field is not that simple as it sounds.
Excellent, thank you. And there's another question. If I understand it correctly, do you have any internal style guides or conventions or tools that help people to find functionality or components that are already existing, even though they might not know the exact terminology used or the names of those components? How do you avoid rebuilding the same thing over and over again?
Yeah, so that's something we can still do a better job. Like we used to use a thing called Style Guidist, where you have Style Guide is basically scans your components folder, and if there's like a README markdown file, it actually builds you like a list of the components, but it had to be run as a separate process and people just forget about it and get outdated. So what right now we do is we just have a flat structure of components. And by flat, and this is the reason we actually have a flat structure of components. By flat structure, what I mean is when we have our components folder, and we say we have a component. Let's say we have a text component, we have a button component, and those again, obviously they will be separate. But let's say, before, for example, we have a post item component, we had post vote component, post vote button, let's say, and there was a point where we just were nesting components like this. We will have like a post folder where we're going to group all the post related components because it makes sense for them together. But the reason we make this flat is because you just open a flat directory and you actually see all the names listed alphabetically. And we have rules how to name those components. Like, for example, we use suffixes for buttons, like everything which is a button is a button. We use a suffix for inputs when something is an input, like a form input. Like, for example, oh no, actually sorry, what I mean here is input text, input topic. And for example, if you just care, when you just open the folder, you just see it. And this is something that people just get used to. And we have like quite a bit of those components. And after like week or two, you have used most of them, especially the flex components, tech components, button components.
Yeah, makes sense. Here's another one. What do you use as a module bundler, and what is the output target?
I mean, we use Webpack, and that's actually the best feature of Next.js. Next.js handles all of that. Like Next.js hides Webpack from us. It hides half of Babel away. So and this was something we still struggle at PH. We had this massive Webpack configuration with a lot of bundling and crazy shit, and Next.js just hides this from us. Like if Next.js tomorrow decide to use the new fancy bundler, and they just use it, and we don't care because we don't change our code. And this is one important thing for us, because and we trust Next.js there. So we basically use Webpack, but in truth, we just use Next.js bundling because they also have their own code splitting rules, which are very applicable to the way we have our application.
All right. So do you have the functionality to pre-fill a form on a particular event from outside of the form scope? That's the question.
Yeah, we have this. Basically, we have a hook which which is a wrapper, of course. I mean, we're very big into wrapping, which have like, basically you can say use form state, and this returns you a form object. And this form object, you can say set value, and you can say whatever name is something. Like you can basically have this in a component. I mean, it has to be in the form context because you need to have access to it. But this is how we actually can interact with the form state outside of the form components. They are not like as black boxes we need. And we added this quite recently for like a very particular feature.
Okay, and two final questions. Do you store the GraphQL queries somewhere so they can be reused by other components?
Yeah, I mean, every component keeps its own queries and fragments. Like we don't reuse the queries, we just reuse the fragments because we use the queries for tracking. Like for example, I mean, for tracking, we have in our backend, we say this query took this time, it was used this many times, and this actually gives us, like for example, we see, oh, this page actually is very heavy to load. And if we just reuse the query, we wouldn't know which page is that and that. But just using the fragments is like most of the time good enough. Like they're very useful. Like we have a lot of queries which are just like, for example, our search component has its own query. Like you give it a query and it searches.
All right. And finally, is it better for performance to have one complex component or to have one complex component or to have separate components for different buttons, for example?
I mean, I haven't seen any performance considerations having many or less buttons. Usually, what I have seen where performance is important is a lot of re-renders. Basically, how you want to control re-rendering. And what I have found out is it's very case by case. Do you need, for example, to have like a, let's say, React should component render on the top of the chain or on the bottom of the chain? Like, do I care? Is this just simple button changing and because of it I render the whole page, or is this total event from the top? But I haven't had any performance that, for example, I have too many components or too less components.
Okay, so thank you, Rado. It was a pleasure having you here. Really interesting presentation. We will now proceed with Hristo.
Thank you. Bye-bye.
Yep. He will tell us more about gRPC Web, which is a really exciting piece of technology. So it's your turn, Hristo.
Okay, thanks, Misho. Can you hear me well?
Absolutely.
Okay, next question. Can you see my screen?
Yep.
Great. Well, hi all. Thanks for joining us, and thanks for staying for this presentation as well. Today we are going to talk about gRPC Web. Before that, I'm going to give you a quick agenda of what we are going to talk. So first, we are going to cover what is gRPC Web, why do we need it, some consent pros. I will make a real-time demo. I also prepared some tips for the end, and again, we will be having a Q&A session in which I hope I will be able to answer your questions. So let's get this started. What is gRPC Web? Before answering that, let's first cover what is gRPC and also what is RPC. So RPC stands for remote procedure call, or simply calling a procedure or a subroutine remotely. To explain this simpler, imagine to, for example, call a procedure on your friend's computer. That's what is remote procedure call. It is kind of old. It's actually older than me. Dates from the early 80s, and it is a request response protocol. gRPC, on the other hand, is pretty new. It's since 2016 on the market. It's an RPC framework, and it's by Google. It's running over HTTP2 and is highly preferred across microservices for communication because it allows microservices to be implemented in different languages because of its language agnostic nature. And it's also fast and efficient thanks to the HTTP2 protocol. And for 2 years, I think, browsers now are also able to use gRPC thanks to the gRPC for web. Why will we need gRPC web? The most important thing is that it's a matter of API design. So it has its pros, it has its cons, like every other architecture. If you have to call a procedure on the server from the browser, or to call an action, for example, imagine that you have a cloud service that is doing some heavy computation in the background and you want to start a computation, then it's a remote procedure call. One very great feature of gRPC is that it offers streaming API. So if you need streams, that's your framework. gRPC is also great because it uses interface definition language thanks to the protocol buffers. And the framework also auto-generates all the client and server stubs for you. So you save time handling requests and also executing requests. Let's quickly see some cons and pros. I'll first start with the cons. One of the cons of gRPC for web is that the documentation is really poor. Or at least it was at the time we at Chaos Group were researching it. That was in the beginning of the year, even before the COVID thing. And we were having hard times making it run in the browser. Thankfully, we were able to find great tools that helped us, but more about that later. Also, the setup of gRPC and gRPC web is not that trivial. But yes, as I said, thankfully there are tools that are making it easier. And the great part here is that once you set up your API, it really pays off later. Another con is that in order to run, in order to have the browser calling RPCs via gRPC for web, the service requires the Envoy proxy, and that's because of the implementation of gRPC. It's, as I said, over HTTP2, and uses the so-called trailers, which are part of the HTTP specification. Unfortunately, browsers do not understand that, and that's why we need that proxy, which overcomplicates a little bit the architecture. But fortunately, at least for Golang, there is an in-memory proxy provided by the guys from Improbable, and I am actually using this proxy in the demo that I'm going to show it in a couple of minutes. Let's take a look at the pros. As I said earlier, it offers language-agnostic API design, and currently gRPC supports the most popular languages, including Golang, C#, C++, PHP, Java, and of course JavaScript. You are able to have your data structured, and that's in contrary to, for example, REST. Also, you can easily version your API, and one of the coolest parts is that gRPC can auto-generates all the client and server stubs that you will need for the requests. As you can imagine, the auto-generated code is awful. It's auto-generated after all. And for the scope of JavaScript, the JavaScript stubs are, I would say, pretty much Javish, because this, as you will see in a couple of minutes, this is not the most popular and natural way of calling functions in JavaScript, but anyway, still you can create an extra wrapper around them so you can consume your APIs easily. And yes, last but not least, the streaming API is a great feature of gRPC. Okay, time for demo. The demo can be found at my GitHub account, github.com/itskata/grpcnotifier. It is a desktop service for reminder notifications. I personally was using for a couple of years a command line tool that I created myself for scheduling reminders. For example, to schedule a reminder for 40-45 minutes to remind me to get off the computer and walk around in order to have my eyes rest and my body moving, and more short-term reminders, but it was very ugly and yeah, without user interface and things like that. So I decided to create a better version of it using gRPC for web, and the application is basically a Golang service that stores the notification in an SQLite database. The UI is served on localhost port 4333, and it can be opened in the browser. And the UI is a simple React application bootstrapped with Create React App. And yeah, let's have a look at it. This is a very first initial version of the application where we can we have two inputs for the notification title and message, and also a preview button that currently does nothing because the RPC call is not yet implemented. Let me show you how the magic happens. So as I said, the implementation of the service is in Golang. I won't focus on that because this is a JavaScript meetup after all. but I'm going to give you an overview of the protobuffer, which is the language of gRPC. So here we use protobuffers to design our API. As you can see, it is a very simple and human readable syntax in which we define the name of our package, and also we have our service definition. It's called Notifier API, and here we define all our remote procedure calls. Right now we have only one, and it's called show notification, and it accepts a request and also returns a response. These are protobuf messages, which we define below. And we can see that the show notification request accepts two parameters. It accepts a title, which is a string, and also a message, which is also a string. And the show notification response is empty because we do not need any response. We will understand if our notification was shown or not thanks to the gRPC status code. This is the remote procedure call is not yet implemented in the UI, but it is implemented in the service. So I am going to test it now. Here's a Bloom RPC, which is a GUI for gRPC requests, and it is very nice for debugging and testing. What I need to do is I have to import my API proto file, and you can see that it lists all my RPCs here, which I can simply load into the application and run. This saves much time and helps a lot. So yes, the service is running at localhost colon 433. And when I execute this, we see this is our system notification that says hello and hello. I can put any text here, and we'll see it in the notification, which is the macOS native notifications. This is pretty much how the client and server are using gRPC. So the server basically uses the API design from the proto files in order to implement the business logic under the hood, and also the client uses the same definition in order to know what are the names of the RPCs and what parameters each request accepts, and also what to expect from the response. Okay, so I will move back to the client side and the UI. As I said, it's right now we have a very simple React application. The UI is from Semantic UI. And we have two inputs and a button, and we have to make this button work somehow. First, let's create the stubs from the proto file. This operation will basically do one thing. It will parse the proto file and will generate all stubs for all supported languages. We are currently interested only in Golang and JavaScript. To do that, I created small bash script can be used for on Unix, and there is also a Windows version, which uses a tool by Uber, which is called ProtoTool. And this ProtoTool is actually a Docker image that is running with Docker, and it has very easy configuration, which allows us to configure what to generate, how we want it, and it does all the magic for us. So that's the easy part, because if we don't use this tool, using the ProtoC from Google is a little bit harder to configure. Okay, let's have a quick look at the ProtoTool configuration. Here we have some generic config, which I copy-pasted from the example of this ProtoTool. And we are interested in these things here. We want to use the gRPC web plugin to generate all we need for the browser. JavaScript, which is these are the requests and responses for all RPCs, which can be used by Node.js and also by the browser, and the Golang stubs. Everything will be generated into the gen directory. And the bash script does exactly this. It tells the ProtoTool to use this configuration and generate all our stubs based on the proto files. Let's have a quick look. I'm going to stop the service now and go to the API and to execute build. Okay, no errors. That's perfect. Yeah, quick look here. This came from the ProtoTool because it's there is also an option to validate and fix your proto files, so they are always valid and have everything that is needed. And all the magic happened here in the gen directory. Here are the stubs for Go, and we are now interested in the JavaScript stubs. You can see there are plain JavaScript stubs and also TypeScript stubs. These are actually the TypeScript definitions. And let's have a look at this. As I said, it's auto-generated code. It definitely looks pretty well. It's commented and well formatted, but anyway, it's bit hard to understand and look at these namespaces. It's kind of too much, but anyway, we are interested here in this notifier API promise client, which is our gRPC client for the web, and we are going to use it in the in our request. So let's get back to the application, and I'm going to now import this guy. So it's from notifier API, it's gen, it's JS, and it's gRPC web. One thing I forgot to tell you is how I added these stubs as a dependency to my UI. It's a simple yarn add. If we go to our UI directory, where is placed our files for the UI. Actually, this was bootstrapped with create React app. We can add this as a dependency like this yarn add API gen. What you have to do is to have a package JSON in your root of the API, so the package manager can properly import it as a node module. And yeah, we can do it like this. Simply, we are going to run yarn init, and it's a wizard that helps us generate this package JSON. Version 0.10 is better here. Description no, entry point doesn't matter. Repository URL, author license, private, okay. And here is our JSON, and we get back to our UI and we add it like this, yarn add API. This is for the purpose for the purposes of the demo. In general, I advise you to keep your API proto buffers and generated stubs in a separate repo, which I think is easier for adding as a dependency. You can then push it to a local npm repo or directly add it as a Git dependency, or if you wish as a submodule. It's up to you. Let's get back to the code. So after we added our dependency, we need to import it in the application, and we need to construct our client, and I would say const client equals new notifier at API promise client, and it accepts hostname, which in our case will be localhost 4333. And that should be enough for now. And we need to implement our show notification request as defined in our proto file. To do that, we need to also import our show notification request, which can be found in the notifier API /gen /js notifier API pb. Okay. And now I'm going to construct my call. I would say const show notification equals async message, and here we need to first construct our notification request, and after that execute the show notification RPC from the client. So let's do it. Let's have const request equals new show notification request. Now, if we get to the API design, we see that the show notification request accepts two parameters, title and message, which are strings. So the gRPC, the Uber proto actually generated all the setters for us. So we need to call here request.set title, and as you can see, it appears as a suggestion in my editor. We set the title and also request.set message. And here is the message. Okay, we are ready with the request. Now we need to send it to the service, and we will be using our client for that purpose. So we say client.show notification, and we pass, as you can see, the show notification request. And because this will return a promise, and we already have an async function, we will have this const response equals await client.show notification. What shall we do with this response? We will simply return it objectized like this, response dot to object, which returns it as a JavaScript object if it contains any data. In this situation, it is empty response, so this actually will return an empty object. Okay, so let's make this work. We have the show notification async function, and we have to call it by passing it the user input. I will use here useState from React. It will help me keep these user inputs into the state, which I will reuse later for the handling of the click of the button. So let's say const notification set notification equals state, and it says title empty string and message also empty string. Okay, and input value notification.title. This will be our value for the title, and on change we need to update our state like this. We have the event here, and we're going to call set notification. We're going to copy the current notification and also set the title, which will be taken from the input, like event.target.value. Pretty long line this is, so it's a little bit like this value. Okay. Same can be done for the message input. Okay. So notification message. Okay. Great. And let's also add the click handler here that will actually shoot our notification to the service. Button on click equals to call our function show notification and pass the notification to it. Okay, let's have a look if this is going to work. I hope so. Fingers crossed. A couple of things here. I have to first build my UI. So I'm going to my UI directory. And since this is a Create React App application, I'll just say yarn build. And it is going to build my files. There is an easy way to develop and preview your changes instantly without having to build, but don't worry about that. I'll cover that in a few minutes. Okay, my files are built in /UI/build directory. And now I have to go to my service, which is the Go service. And I want to build these UI files into my binary, which is called notifier. To do that, I'll first have to create a static build. I'm going to use helper for that command line tool for static Golang builds called static. And I'm saying that I need these files from /UI/build to be bundled into my binary as static files. Okay, we should be ready. And now, okay. And now we should be able to build our application. Okay, so I'm going to build it with Go build as a binary. Okay. No build errors, that's great. ls, that's what I have, a binary built by Go, and I'm going to run it. Notifier. Okay, listening. Let's test. Okay, let's test gRPC web. Fingers crossed. And nothing happened. That's the risk of the live demo. Some errors we have here. Let me see if I can debug them quickly. It says incomplete response. That's interesting because I think everything should be good here. Anyway, I have a backup. I will now check out my live my final version, so I can hopefully show this working to you. But in general, this is how you consume gRPC call in the web browser. You need to first add the generated stubs as dependencies. Then the best thing would be to create a wrapper around these specific expressions, because as you can see, they are not pretty straightforward for usage. much easier will be to have a single function that accepts parameters and returns a promise which resolves with the response data. Okay, let me try to check out the master. Okay, so let's first revert everything we did, so there are no Git conflicts. Okay, and let's get over all of this one more time. First, we need to generate our stubs by using the build script. Okay. Then we need to get to the UI and yes, build what we already have. First, let me ensure that the latest and greatest notifier API stubs will be added as dependency. Come on, come on, come on. Okay, so now we have yarn at okay. Now let's create the build. Come on, come on, come on, come on, come on. Okay. And let's build the binary. First, the static files. And okay, yeah, as you can see, this is the final version of the application. It now has a couple of more things here. A date and time picker to schedule the notification, instant preview, and also a list of all scheduled notifications. So far, we have 0. Let me first check if this is going to work. Test and preview. Oh, it's working. Okay, great. So these are the risks of the live demo. It's always going to fail, but anyway, I wanted to walk you through the whole workflow. And what is going on under the hood? So let's have a look at the network tab. Here I'm going to increase a little bit the font size. Okay, clear everything so far once again. And probably my font size is too big because I can't see, not here, but here in the DevTools, I can't see. Okay, there is the request. As you can see, this is the request. It's a standard HTTP request, and as you can see, it's currently insecure. What I said some time ago was that gRPC requires HTTP2, and as we all know, HTTP2 requires HTTPS. But thankfully, gRPC for Golang allows us to run a gRPC server insecurely, and that's, I would say, great for development and testing purposes. Let's examine this request. So far it looks as a standard HTTP request. It has response headers, request headers, and if we get to the request payload, surprise, this is looks like a base64 encoded string, and that's the nature of gRPC for web. All requests are encoded, sent to the service, and the responses are also decoded from base64 and returned. This is not easy for debugging, not easy at all. Thankfully, there is a browser extension called gRPC Web Developer Tools. It's available for Chrome and Firefox, which gives us easier debugging of gRPC for web requests. When you install it in your browser, it will appear as a new tab in the DevTools, at least in Chrome. I haven't tested that in Firefox. So it says now recording gRPC network, perform a request or hit reload. So we are now performing the same request in order to debug it. Okay, and that's our request. And now we see more meaningful data here. That's what we really called our request, and these are the parameters of our request. The title and the message, and also the response, which in this particular example is empty. Okay, let's move forward. Let's schedule a notification that will appear in 1 or 2 minutes. I'm going to reload, and I'm going to use this sort of fancy date picker. I'm going to schedule one notification after 1 minute. It's actually 6:38, so we might have missed it. Okay, so I'm going to schedule another one for 6:39. And let's wait, and fingers crossed. So we have it in a minute or so. Since it's OS notification, it will appear no matter what I'm doing. I wanted to quickly show you how to easily develop your user interface without having to build and rebuild. There's the notification. So great, it's working. So you don't have to build every time the UI and the binary and etc. As I said, this is a Create React application, and and we can start it with a yarn start, and it will open the UI on localhost port 3000, and it will still call our service, RPC web, blah, blah, blah. You see it's working. So how this magic actually happens? Thanks to the HTTP proxy middleware that can be integrated to our Create React app. And here we define a proxy saying that all /notifier something requests are proxied to our real service, which can be found at localhost 4333. And let me get back to my presentation. Yeah, the demo is available on GitHub. I tried to provide installation steps in the README. I haven't tested them, to be honest. So if you see any issues, just write me and I'll try to fix them. Okay, let's get back to the presentation. Some tips for final. As I said, keep this is some piece of advice: keep your protobufs and generated stubs in a separate repo, because I kept them in the same repo for this demo, but it will overcomplicate development if you have to update your API too often. And since they are in a separate repo, generation can be part of your pipeline. You can validate your proto files. You can generate stubs. You can generate documentation. All this with the Uber's proto tool. Yes, as it's said on the slide, it will definitely make your life much easier because it does the heavy lifting for you for generating all the stubs, and it's easy to use. gRPC Web DevTools extension is your best friend. As you saw, debugging gRPC requests in the native DevTools is not actually possible. So this is actually a must. Bloom RPC GUI is very, very good for helping you that everything is right and okay with your service, and the problem you are counting is somewhere in your gRPC Web integration. It's available, I think, for all platforms. It is very, very easy to use. And yes, as I said, don't over-engineer. If you need a simple resource-oriented API, for example, just go REST. Don't make your lives harder. And I think that's it. So some time for questions and answers.
Thanks, Ito. It was really interesting. Although I've seen it all, but it's still pretty cool. There's a question in the chat, and I'd like to ask you all to post more questions if you have some. So you already showed us the Chrome DevTools plugin. And another question is, how do you integrate gRPC Web with the state management library? And what do you use for state management?
Well, at Chaos Group, we are using Redux and Redux Saga. So basically, all the business logic for requests is part of the sagas. And once we get what we need, it's simply stored into the Redux store. And this architecture, I would say, works for us. I was planning to use the very popular these days React query in this demo. Unfortunately, I didn't have enough time for it, and I was afraid that I won't be ready for this demo, so I had to throw this idea away. But I can do that in the next couple of days. We'll try React query in this demo that I already shown, and see it in action. Just follow me on GitHub, and hopefully you see an update soon.
All right, next question, and that's actually one that I was also planning to ask you. But do you have experience with the streaming API? And actually, what's the streaming API? What can you use it for? And what have you used it for?
Well, the streaming KPI is used when you when simply performing an unary call won't do the job. You need to constantly receive response in the form of the stream. And yes, the answer is that we are using the streaming KPI in one of our products at Chaos Group. I was actually thinking to use it in this demo too, for the following purpose: to listen for new notifications that are scheduled from outside the web UI and show them instantly. For instance, to schedule a notification through the Bloom RPC client and make it appear instantly in the browser. But unfortunately, I did not have time for this too. But yeah, that's also an option for the future version.
All right, and now another question. Can you compare your implementation with Improbable Web's gRPC implementation? I'm not sure if the...
I think
Okay.
I think I understand the question, and I think the question is regarding gRPC Web. Yes, Improbable provide their implementation of the gRPC Web, which in fact we were using in the very early stages of our product at Chaos Group. But down the road, we switched to the native gRPC Web provided by Google. But still, and in this demo application too, it uses the in-memory proxy by Improbable in the Golang service. I'm not sure I am able to compare them because I, to be honest, did not get so deep into the technical details under their implementations. But if I remember well, the Improbable's gRPC Web didn't base64 encoded and decoded the requests and responses. They used some their serialization, if I'm not wrong.
Okay, thanks for that. And that was the last question we have currently. Oh no, there's another one. In which situations would you choose REST or something else, maybe like GraphQL or something, over gRPC?
Well, if you deal with data, GraphQL or REST are perfect. If you want your clients to be able to have the ability to fetch only what they need in a single request and in the structure they need it, then and you deal with data, then it's definitely GraphQL. For something simple, resource-oriented, REST should be fine in most cases. And gRPC Web for streaming APIs, and as I said, if we have this, if we have to call an action. So in my understanding, if I have to call actions on my to my service, like to show notification on the operating system, for example, or to run a cloud job or something like that, I would use gRPC, because it's what it stands for. It's remote procedure call.
So as you said earlier, mostly a matter of API design.
A matter of API design. You can use GraphQL to call an action remotely, but it will be a poor design.
Right. Okay. So I see no further questions. I want to thank Ito for this presentation, and Rado as well for his presentation. And I want to thank you all for joining us today. It was very good questions in the chat. I'd like to ask you to participate in the feedback form that you receive by email after the event. There will be prizes there, so please do it. And it also helps us make this event better and better for you. This is just one in the series of events, so stay tuned for more Total Chaos meetups. We will decide on the organization depending on the COVID situation. So maybe it can be in person, maybe it will be online. Just stay tuned. All of our upcoming events will be announced on our newish Facebook page called Chaos Bulgaria. So follow that for updates. And yeah, that's it from us. Thank you all. Have a great evening.
Thank you all. Thanks for listening, and bye-bye.